Okay, so stats. So 5, 7. So really, this is the most important section involving normal distributions, normal probability distributions, because we're going to use context now. We're going to give you a problem that involves a mean and a standard deviation. But your job is going to be able to use the standard normal distribution to then interpret this problem and answer the question. All right, so if we look at this next slide here. So when you're looking for probabilities, okay, so in this picture, right, we have some normal distribution. So the first step when finding probabilities, and again, remember, if you're finding a probability, that means you're finding an area under the curve, right? You're going to draw a normal distribution, and we're actually going to draw a standard normal distribution. Okay, and we're going to mark the mu equal to 0, and your standard deviations of 1, 2, and 3, and then -1, -2, and -3, right? We're always going to do this with the standard normal. Okay, then we're going to find a z-score that's going to go along with our boundary value or values, right? They could give us two numbers, they could give us one number. So notice here in this chart here, this is not the standard normal distribution. This is the actual, whatever, this is the mean, and then this distance here would be the standard deviation. Again, we're going to focus more on this because, as you can see, no matter if you use the actual numbers or the standardized numbers, the areas correspond, and the actual value, so in this case, the actual x value, is going to be in the same place as the z value that corresponds to it. So again, same area, right? Same answer, same probability, just standardized is a lot simpler. So that's what we're going to do. So you're going to use the z-score formula to find that standardized value. And here it is right here again. And then we'll use the stats output to find the probability. And we'll answer the question, usually involving an interpretation. Okay. All right. So let's go ahead and begin. All right, so example one says, is Rory McIlroy a longer driver? On the driving range, Rory McIlroy practices his swing with a particular club by hitting many golf balls. Many golf balls, right? Chance process, many repetitions. Let X equal the distance the ball travels on a randomly selected shot with his driver. Suppose that X follows a normal distribution, so normal distribution, with a mean of 304. So your mean is 304 yards and a standard deviation of 8 yards. Find and interpret, don't ignore that word, this probability. Okay, so we're going to be finding a probability. So the first thing I want you to do is I want you to get the z-score, right? This is the x value you get. So to find your z-score, we're going to take the x minus the mean and divide it by the standard deviation. Okay, I'm going to do this in the graphing calculator to show you how exactly to put this in. This is going to go away. So in the Desmos graphing calculator, let me erase all this fun stuff. Okay, so the first thing I would do is press the fraction bar, and you're going to do 290 minus 304, and then divide that by 8. And there is your z-score, negative 1.75. Now, usually we do 3 decimals, but it did not have 3 decimals, so that is okay. Negative 1.75. So, back on here. Instead of finding the probability that x is greater than or equal to 290, we're going to find the probability that z is greater than or equal to negative 1.75. This is the probability we will find. So I'm going to take a picture of that, and we're going to finish this problem on the stats applet. Okay, so let's go to the stats applet. Here we go, stats applet. Find the stats applet probability. I'm looking at a normal distribution here. Again, I'm calculating an area because I'm finding a probability. Our mean is always 0. Our standard deviation is always 1. Always 0, always 1. And now I want to calculate the area. And now, remember, we are trying to find the probability that z is greater than or equal to negative 1.75. So greater than means more than, to the right of, and our value is negative 1.75. And there is your probability, 0.9599, 0.9599. So that is the probability I was looking for, and now we have to answer it. And here is the answer. The interpretation there is about a 95.99% chance that a randomly selected shot with McIlroy's driver will travel. Now, you could do a couple things. You could be very slick and you could say at least 290 yards. So you could say it like that. Or you could say, we'll travel 290 or more yards. 290 yards or more. However you want to end it is fine. I like that at least. I think it's kind of smooth, right? At least. But it's whatever you want to do. Okay. All right. So let's do one more that involves multiple. You'll also have to again take a picture of this. So what you would do is you would take a picture, and here's what I want you to you just take a picture and add that to there. Okay. But again, what does this picture mean real fast? I guess I did not explain that. So what this picture means is that this is your z value of 1.75 negative, and then that is your area of 0.9599. Okay, and again, if you use the mean and standard deviation they gave you in the problem with the 304 and the 8 yards, you would get the exact same picture. But again, we are all about standardized and the standard normal distribution. All right, cool beans. Next problem coming right away. Let's go back to our notes. Okay, it's a 2 for 1 in this objective. All right, so next it says a same kind of problem. On the driving range, Rory Mcllroy practices a swing with a particular club by hitting many, many golf balls. Let X be the distance the ball travels on a randomly selected shot with his driver. Suppose that X follows a normal distribution with mean of 304 and standard deviation of 8. So again, normal distribution, your mean is 304, your standard deviation is 8. What percent of Rory's drives travel between 305 and 325 yards? So I'm trying to find the probability that X is in between 305 and 325. So now I have two boundary values I have to worry about. So the first thing I'm going to do is I'm going to standardize each of them. I'm going to find the z-score associated with each of those values. So z equals 305 minus 304 divided by 8, and z equals 325 minus 304 divided by 8. And I will take a picture, and we'll go ahead and do that on our Desmos graphing calculator. All right, so if I come here, so the first one was fraction bar, 305 minus 304 divided by 8. So 0.125, and the other one is 325 minus 304. Oh, sorry, get the fraction first. Get ahead of myself. Fraction. 325 minus 304 divided by 8, and 2.625. So those are the two values that my z is going to be in between. So when I come back to, I'm going to go to the stats applet, because I'm going to write there. Let's reset everything. Let's just go back here. Probability. When you go there, make sure you do a normal distribution. Okay, so before I type things in, the problem was find the probability that 305 is less than X is less than 325. That has now changed, and find the probability that 0.125 is less than Z is less than 2.625. So now, on my standard normal distribution, I'm still calculating area because I want the probability. When it said percentage, right, that just is the probability written as a percent. So my mean is 0. My standard deviation is always 1. Standard normal curve. I am now going to calculate the area between two values, and those two values are 0.125, the left number, and 2.625, the right number. And that is my picture. Here is my probability. This probability equals 0.4459. So your percentage is 44.59%. And again, it's going to ask you to include the picture. So somehow or another, you have to copy and paste this picture. But again, what does this represent? There's your 0.125, there's your 0.6 or 2.625, and that is your area of 0.4459. Again, to the right of the mean, so it's going to be around zero point 0.5, but notice it does not include that tail or this part. So it's a little bit less than 0.5. All right, that was objective one. That's the forwards way. Now we're going to take a look at objective two, which is the working backwards, if you recall.